So we're going to calculate the integral of t to the 5th e to the t cubed, and as we can see, it's not a straightforward u sub, so we might think integration by parts. We could start using integration by parts here, but it could get a little messy. We're going to use u substitution to help us out before using integration by parts. So it's a little bit of a tricky substitution. What I notice is that t cubed, and there is a factor of t cubed in here. So it's really neat how this ends up working out. I'm going to let u equal t cubed, or actually let's not use u because we are going to need integration by parts, and I don't want to have too many u's. So let's use x. X is t cubed, then dx is 3t squared dt. Now, what's nice about the exponent on this t is 5 is a 2 plus 3, and that's what is going to make this one work. Because what I'm going to do is I'm going to split up the t to the 5th. I'm going to put a t to the cubed in front of the t to the cube, and then I'm going to have a t squared dt. Now, I need it to be a 3t squared dt, so what I'm going to do is I'm going to put in the 3 in front of the t squared, and to balance that out, I'm going to put a 1/3 out front. That 3 times the 1/3 multiplied together will cancel each other out. So now we can do our u substitution, which I'm actually using x for, so I guess we could call it just substitution. So I got 1/3 t cubed I know is equal to x, so that becomes x e to the x, and that part there is just my dx. And now we get down to a actually pretty simple integration by parts. I'm going to let my u equal x, and my dv equal e to the x dx. V equals the antiderivative of that, which is e to the x, and du just equals dx. So I have 1/3, and now I'm going to put in x e to the x minus the integral of v du e to the x dx. And I got a basic antiderivative there. We'll need a plus c. So we got 1/3 x e to the x. We'll multiply that 1/3 in later. The antiderivative of e to the x is e to the x plus c. So we have let's write it over 3. So we have x e to the x over 3 minus e to the x over 3 plus c. Or if you want to leave the 1/3 factored out, that's fine. But we're not quite done. This integral started in terms of t. It needs to end in terms of t. Specifically, we know that x equals t cubed. So making that substitution in for our x's, we get t cubed e to the t cubed over 3 minus e to the t cubed over 3 plus c, and there is our antiderivative.